Let's look at the question valid mountain array. We are given an array of integer L. Only if it is a valid mountain array, return true. So recall that L is a mountain array only if it meets the following three conditions. The first condition, the array length should be greater or equal to 3. This means that it has at least 3 elements. The first element is the valley, the second is the peak, and the third is also a valid. And the third condition, there exists some elements. The indexes are from the 0 is less than I, and I is less than the length of the array minus 1. And so this is the array you arranged in this order, right? The indexes. Now let's take more deeply. We start from the array at 0. It is a valid, and L at 0 is less than L at 1 is less than blah blah blah, less than L at I minus 1 is less than L at I. So this is a upslope, and L at I is a peak. Then the L at I is greater than L at I plus 1 is greater than blah blah blah, blah and greater than the L at the length of the L minus 1. So this is a downslope, and we end at the L at the L's length minus 1. This is a valid. This is how mountain arrays are formed. It is very easy to keep track of a monotonic increasing or decreasing ordering of elements. You just need to be able to determine the start of the valid in mountain, and from that point onward, it should be a valid, like there's no mini hills or slopes after that. So using this information in grad to the values in array, and you will be able to come up with a straightforward solution. So first, we have an array A have 8 elements here, and we start at A at 0, and because the length is n, so the last number is n minus 1 index, and let's initialize I, start from 0, and we used A at I to compare with A at I plus 1, and after compare we just increment I, increment 1 by 1 by 1, moved from the left to the right, and so the first part is the A at I less than A at I plus 1, and the second part is A at I is bigger than I plus 1. So the first part is up slope, and the second part is down slope, right? And then finally, because we move the I from left to the right, they increment by 1. So finally, the I will reach the final index. We need to compare whether I is the n minus 1. If it is, we just return true. So here we just return true because it is true. So let's implement the code in Python. Class solution object, and we need to define a function valid mountain array. So inside is a parameter self and A, and we initialize we have a length is a n of the array, and I is initialized from 0. So if I want to walk a mountain from left to right, we have to move strictly up, then strictly down. So let's first walk from left to right until we can. So there will have be a peak. Well, I plus 1 is less than n. So we need to keep the I is always less than n, so that it is inside the whole array, and meanwhile A at I is less than the right side A at I plus 1, and then I is incremented. I is always from shift from left to right, and meanwhile we should. So this is the first. Meanwhile, we should first keep the peak is not the first or the last. So if I is 0, this means that I is in the first, or I is the last n minus 1. So we return false, and we have to keep walk down because we just meet the peak. Well, I is plus 1 less than n. So we need to keep the I always in the array, and A at I is bigger than A at I plus 1. This way means the left side is bigger than right side. That means it starts down slope, and I is incremented by 1, and so this ensures the array is valid and otherwise not. So if the element passed the test, pass the condition, so we can return I is comparable to the n minus 1 to check out whether it is passed, when it is to get the final one. So we just finish the function, and we need to analyze the time is O of n, because n is the length of the array, and we just keep track of the whole array, and the space is very easy. Just O of n, O of 1 is we just don't use any extra space. We just traverse the whole array, right? So we can, after we define, we can print out the solution dot well. Now we get the here, input data here, and then run out, and yes, it is first, and we can run out the last of them. Yes, it works. First, false, true, and false. Yes.